All right. Here we are on this Tuesday evening. For some reason, yesterday I thought it was Sunday. I don't know why. But it is Tuesday. And we are live with some calculus. So welcome on in to those of you just joining us. I'm going to go ahead and start looking at my chat and seeing if there's anybody in here that I can click the button to wave to. But if not, I'll wave to you right now. So tonight, we're going to be talking about intermediate value theorem, or IVT for short. So let me go ahead and write that down. So, intermediate value. Hey, climb back, how's it going? Welcome on in. And again, for those of you who are just joining us, hey, how's it going? Welcome on in. So, yeah. As I said, if I can't wave at you by clicking the button in a couple minutes, I will wave at you physically. So, tonight, as I said, tonight, we're going to continue our talk on continuity by discussing the intermediate value theorem. Hey, Hefe. Oh, you said your students had a test today. How's it looking? I think it was you that said that your students had a test today. Hopefully it was. You haven't looked at it, I'm going to... Smart. Very smart. Any initial reactions from your students? Today was a long day. Indeed it was. What happened, if you don't mind my asking? Some of them finished really fast, so that's either good or bad. Yeah, in my experience, yeah, there's going to be no middle ground for those students. It's not going to be like, oh, you got a B. No, it's going to be like, you either got an A or you failed. You stayed late to prepare some lessons and assignments. Okay, cool. How many questions did you have on your exam? I had my real analysis exam yesterday. Where were you last week to review? I was right here. Although I haven't done real analysis in ages. Thank you, Beyond, for the follow. So, as I said, tonight, we're going to be talking about this intermediate value theorem. So, as I said, it was just a quiz, unit 1.1 to 1.4. Okay. Cool. But yes, if you could hit that heart button, just do a mad tap right now, and we will get started. Oh, also, for those of you who just joined us, and I can't click a button to say hi to you, I'm going to wave at you right now. There we go. So, there we go. Now we're getting the heart. Now we're getting the Now we're getting the hearts going. For extra credit, I asked them to name who was credited with discovering calculus. They had to say they had to say both first and last names. Okay. Interesting. What's your opinion on that debate, Hefe? How much in percentage wise does AP Physics have AP Calculus related stuff in it? I actually don't know. I haven't taken a look at the I haven't taken a look at the AP curriculum. Oh God, what is Leibniz's first name? It's like notes. I think it starts with a W. All right. Gottfried, that's right. You need help with your homework? Okay. What topic are you doing, Nebulae? Can you help with an IVT question I have? Sure. Put it in the chat and I will add it to the list of problems that we do tonight. Can you start? This is exactly what we're doing right now. Yeah, I can start. I just like to take a few moments before, at the beginning, to say hi to everyone and see how everyone's doing. Like I said, my goal with these lives is to basically just sit back, relax, and have a good time. Yeah, it's not about how fast we get through something. It's about getting to the point. It's about understanding, and if it means that I for those of you who are regulars in here, you know that sometimes I'll start a problem, look at the chat quickly, and spend 10 minutes just reading through a chat. It's a habit I need to get out of, but at the same time, I like doing that because I like audience participation. Best advice to get an A through the entire semester of AP Calc. No rush, it's just late for me, but no problem. We're going to get started in just a moment, Daniela. Best advice to get an A throughout the entire semester for AP Calc. Really, my best advice is to stay on top of the material. I think that if you have a really good understanding of what comes before, if you have a really good handle on your algebra, you're gonna do, and your trig, you're gonna do fine. But also, just because if you're not at that point where you're understanding it, don't be afraid to ask for help, and make sure you practice. Make sure you practice, because while practice doesn't make perfect, it definitely helps you improve. So we are almost at 1K likes already, and we're not even 10 minutes in. All right. So as soon as we get to 1K likes, we will go ahead and begin. Nine more. There we go. Awesome. You put the question in. For some reason, Nebula, I can't see it. But anyway, I said we would start at 1K likes, and we are going to start. So, do I see it now? No. If you want, message me the question. I have my phone right next to me, so if you want, just send me a message and I'll be able to see it there. My phone will give me a notification that you're sending it. But yeah, so let's go ahead and get started with IVT. So here, I wrote a little note card of what the intermediate value theorem is. So, intermediate value theorem, or as I'm going to refer to it for the rest of the evening, IVT. So what does IVT say? Well, it says let f be continuous. There we go. Just because we're doing math doesn't mean we can't have proper grammar either. Let f be continuous on the closed interval AB. If z is any real number between f of a and f of b, then there exists a number c in the closed interval ab such that f of c equals z. So that's great, but what does that look like? So let me go ahead and attempt to show you. So I'm going to let this point be A, and I'm going to let this point be B. So I'm going to draw a function. Yep, I got it, Nebula. So I will add that one to the list. Actually, we might start with that one. Or maybe not. We'll do it, though. So let me draw a function. So what do I want to draw? I want to draw that. So what does IVT say? Well, remember, f is continuous, so this is f, and it's going to be continuous because I can draw it without lifting my pencil, or my pen in this case. And I'm going to let z be a number in between f of a and f of b. So I'm going to say that f of a is over here. I'm going to let that be f of a. And I'm going to let this, I have to be careful here, be f of b. And I'm going to let this point be, I'm going to let this be, I'm going to let this be z, because remember, z has to be between f of a and f of b. Thank you, Jacob, for the follow. So so on this graph, there's going to exist a point because f of a and f of b, or because z is between f of a and f of b. Then there's going to be a number c between a and b where f of c is equal to z. Let's see where that is. So I'm going to approximate here. I'm going to eyeball. So we're going to say that c is right there. And again, I'm just drawing a random function just to show it works. So that is the basic idea of intermediate value theorem. So let's go ahead and start. So with this, show your work is what your professors always say, smart. And the thing about showing your work is this. Wow, 52 people in here. Let's go. Thank you, everyone. So the thing about showing your work is this. When I once told my middle schoolers that the reason why teachers ask you to show your work is not because we want to create more work for you, because let's face it, if we want to minimize our work, then we're not going to ask you to show your work, because having to look over and look at partial credit is time consuming. But the reason why we ask you to show your work is because it helps us figure out where people are struggling, if they're struggling. And if enough people are struggling on the same thing, it tells me, maybe that means I need to teach this differently, or in a way that more people are going to understand. Thank you, Tomas, for the follow. So that's why that's why as a teacher I ask people to show their work. It's not like that. It's not because I want to create more work for you, because it's more work for me. Thank you, Raul, for the follow. So, here, I'm going to let's do our first example of the night. So, example 1. Show that the equation has a root on the given interval, So, I have f of x is equal, or I don't even need to write f of x. I can just write this. I can write 2x cubed minus 6x plus 1 equals 0. And I want to show that this equation has a root on the interval from 1 to 2. So remember the rule that if f is continuous, on the closed interval AB, then if z is any real number, might help if I spell the words right, yes. So, between f of A and f of B, then there exists a number c in AB such that f of c is equal to z. So let's go ahead. Thank you, Heather, for the follow. So let's go ahead and show this to be the case. Well, first, I need to check and see if this is continuous on my interval. So remember the test for continuity that we did last night. Remember that a function is continuous. Wow, is that, there we go. That's better. I think that's better. A function f is continuous at a point if f is defined at that point, the true limit exists, and the true limit equals that point. Now, I'm gonna give you a little cheat code here. This is going to be continuous. How do I know that? What do you think? How do I know? Thank you, TK, for the follow. How do I know that this function is continuous? Sean says polynomial. Gamini says it's a cubic function. Right. So polynomials, especially where I'm not dividing by anything, are going to be continuous. So if I have something like x squared minus 6, I can tell, because this is a polynomial, or even just x squared, this is going to be continuous. Why? Because there's no chance of division by 0, and there's no chance of this ever going to I. So, and all of these functions tonight that I want to show you, or most of them, they're going to be continuous. So we know that this is a continuous function. So we want to know, we want to show that there's a root on the given interval. What is a root? Well, a root is where the function is equal to 0. So here, in order for me to show that there's a root on this interval, I need to prove that 0 is in between f of 1 and f of 2. So let's do that. So I'm going to plug in f of 1 first. So f of 1 is equal to 2 cubed, or 2 times 1 cubed, minus 6 times 1 plus 1. Plugging in 1, what would my function give me? Thank you, Fernando Medina, for the follow. Thank you for the follows, and thank you for the likes, everyone. Santiago says -3. Michael says -3. Yeah, so 2 times 1 cubed. 1 cubed gives me 1. 1 times 2 gives me 2. -6 times 1, that gives me -6. And plus 6. And plus 1 comes along for the ride. 2 minus 6 is -4. And -4 plus 1 is going to give me -3. Almost forgot the negative there. Is it just me or am I lagging? I did for a sec. How about now? Am I good? Am I good? Awesome. Thank you. Yeah, I don't know why that happened. It must have been a lag spike or something. Seems okay now? Perfect. So what I'm going to do now is I'm just going to plug in 2 for x. So I have 2 times 2 cubed. Can we do Stokes' theorem? So that is going to, so that would be involving line and surface integrals, and I want to stick to intermediate value theorem tonight. I can add it to the list. So let me go ahead and do that. I can add Stokes' theorem to the list, but I can't guarantee that we'll be doing it soon. He goes, right. No problem, and thank you for the follow, Cambay. So, now, if I plug in 2, what would my value be? What would my value be by plugging in 2? All right, Gamini says 5. Mr. 705, welcome on in. You say 5. Michael says 5. So it looks like we've come to a consensus and said it's 5. Let's check. So I have 2 cubed is going to be 8, and 8 times 2 gives me 16. Negative 6 times 2 gives me negative 12 plus 1. 16 minus 12 is 4, and 4 plus 1 is 5. So now I know what f of 1 and f of 2 are. Now I need to answer this question. Is z between -3 and 5? Well, z, because I want to have a root, it means I'm looking at 0. So is 0 between -3 and 5? Is that a true statement or a false statement? I promise this isn't a trick question. There we go. Yeah. Michael says yes. Mr. 705 says true. Santiago says true. Yeah. Exactly. Yes, Gamini, it is true. So -3. 0 is between -3 and 5. So, remember what the intermediate value theorem says. It says that if this is continuous and z is any real number between f of a and f of b, which it is, then there exists a number c in that closed interval such that f of c is z. So therefore, we have shown, so let me go over here. Therefore, remember 3 dots in a triangle formation mean therefore. By intermediate value theorem, there is a root, or of a function. The function has a root on not of, on the interval. It might help if I move this, yes? Interval 1 to 2. And that's it. Any questions so far? And before you, is this pre-calc? No, Bacon, this is calculus. Great name, by the way. Awesome name. Thank you, Bacon, for the follow. So, shall we try another one like this? I think we shall. Let's try another one. So, let's see, what do we got? Let's do this one. So, here I will move on to my next example. Hey Adonis, how's it going? So, example. So, use the intermediate value theorem to show that (3 x to the 5th minus 4x squared equals 3) is solvable on the interval Thank you, Emiliano, for the follow. On the interval 0, 2. So here, remember our goal. We want to show, this says, in other words, show that there is a number C in 0, 2 such that f of C equals 3. So if you see a problem like this, this is the translation. So it wants us to, it doesn't necessarily, so when we do this, it doesn't necessarily want us to find C. It just wants us to show that the it's solvable, meaning that there is a value of x, such that this is true in this interval. So let's go ahead and do that. So my first step is to ask if this function is continuous. Is 3x to the 5th minus 4x squared continuous? Or should I say continuous on this interval? What do you think? Santiago says, yep. Yeah, again, this is a polynomial, and like I said, I'm not dividing by anything, so there's no chance of division by 0, and there's no value in the real number system that will give me I, so this must be continuous. So, let's go ahead and show this. So, I'm going to find f of 0 and f of 2. And the goal, show that 3 is in between these two numbers. If we can do that, then we've solved this problem. Then we're going to be done this problem. So what I'm going to do is I'm going to ignore this 3. So I'm going to pretend like it doesn't exist. So what I'm going to do is I'm going to cover it up with a glue stick cap. And I'm only going to worry about what's on the other side or what's not covered up by the glue stick cap. So I have 3x to the 5th minus 4x squared. So I'm going to plug in 0 everywhere I see an x. So I have 3 times 0 to the 5th minus 4 times 0 squared. Plugging in 0, what would my answer be? User says 0. Mon says -1. Okay. Remember what happens when you multiply by 0. Control Lucas, welcome on in. And welcome on in, Mon and User. Lucas says 0. Cat says yes. Welcome on in, Cat. So here, yeah, Lynn, welcome on in, Lynn. So 0 to any power is 0. That is mostly true. The only exception is this. Right, yes. So this is actually indeterminate form. This does not equal 1. And it's weird, right? Because we learn in algebra that anything raised to 0 is 1. That's true, except if x is 0. What does indeterminate mean? Sure, so indeterminate means that that it doesn't exist. Like 0 over 0, infinity over infinity. Those are two forms of indeterminate form. So Function doesn't exist at that point. No problem, Mon. Glad to help. So, thank you, Mon, for the follow. So, yeah. So, if I plug in 0, I get 0 to the 5th is 0. And 3 times 0 is 0. Minus 4 times 0 squared. 0 squared is 0. And negative 4 times 0 is 0. So, 0 minus 0 is 0. I almost kind of, when I multiply by 0, I almost kind of think of it as like a black hole, right? Nothing can escape 0 when you're dividing by, when you're multiplying by 0. IVT, MVT, EVT, the trifecta of Calc 1, yes. And then there are the 2 fundamental theorems of calculus, yes. We're going to get to those in a little while. So now, let's go ahead and plug in 2 and see what I get. So I have 2 to the 5th minus 4 times, nope, not 0, 2 squared. User already says 80. I was actually just about to ask what this would equal, user, but I see that you already got it. Or, Hefe says 80. Let's see if you're right. So, 2 to the 5th, that's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times, yes. Yeah, 16 times 2 is 32. 32 times 3 gives me 96. So this is going to be 96. Minus 4 times 2 squared. 2 squared is 4. 4 times 4 is 16. 96 minus 16 is indeed 80. Do you also go over Calc BC? I'm struggling. Yep, I do. I do indeed. So, I'm struggling. Do you also go over Calc BC? I'm struggling on sequences and series. Yes, I do go over Calc BC. And if you need help with that, I'm not going to be doing those tonight, but feel free to shoot me a message, and I'll hi, I'm in Calc 3, but I feel like I'm pre-Cal level right now. Lol. Okay. How did you do in Calc 1 and Calc 2, L? Were they dubs or were they massive L's? Okay, I'll stop. I'm not my generation of slang has come and gone. And I'm sure that was like 3 seconds of cringe right there. You got an A in Calc 1 and a C in Calc 2. Okay. Well, most people say, L, that Calc 2 is harder than Calc 3. But I can definitely help you with Calc 3 if you need it. Feel free, if you do. Oh, okay, it was my first day today. Just no problem. No problem at all. Yeah. Calc 3 is gonna look scarier than it actually is. The main difference is that in Calc 3, you're going to be dealing in multiple dimensions and more than one variable at a time. Whereas with Calc 1 and Calc 2, which is single variable calculus, we only deal with one variable at a time. And you're also going to deal with vectors in Calc 3. I can't forget that. Thank you, L, for the follow. And actually, Nebula, if you're still here, I'm going to write down that problem so that way I don't forget. Because if I don't, I'm going to forget. I'm going to be honest with you. cool. Yeah. All right. So let's finish this problem. Is positive 3 between 0 and 80? Again, not a trick question. Or I'm not trying to give you a trick question here. Have we shown this? Mr. 705 says yes. User says C. Santiago says yes. Yeah, we have. So 3 is in between 0 and 80. Therefore, so 0 is less than 3, less than 80. Therefore, by IVT, (3x to the 5th minus 4x squared equals 3) is solvable on the interval 0, 2. Right, yes. And again, that's it. Any questions so far? Let's take a moment, take a step back and see if we have any questions. And if you're learning something new, or if you're starting to understand this, go ahead and let me see those hearts. Or even if you do understand this, let's see some hearts. There we go. Awesome. Yeah. So, as I said before, does anyone here have any questions? As I said before, my job is to make sure that we're doing math at a nice, relaxing pace. It's like a Sunday drive. Speaking of which, for some reason, I don't know if a lot of you were in here when I did this, but for some reason I thought yesterday was Sunday. I don't know why, but I thought yesterday was Sunday when it was actually Monday. Today's Tuesday. Well, now it's Wednesday over here on the East Coast, but yeah, so always interesting. So yeah, if you are typing out a question, feel free to continue typing. And we will go ahead and we'll do one more like this, and then we'll go into Nebula's question. Does doing this late mess up your sleep schedule? A little bit. But if people are, I've been a night owl for years, so it's not really as bad as it would be. The only time it's really bad is if I have to get up early the next morning. But no, I have some things to do tomorrow, but nothing like time, like pressing for time early in the morning. Yeah, and it's weird because I used to teach, and I used to have to get up at like 5 in the morning after grading and doing that stuff, and it wasn't very sustainable. Could you show Laplace transform? So tonight I'm gonna be working with intermediate value theorem, but I can add it to the list D. Let me do that now. Oh, by the way, I found the other list. Do I ever plan on going back to the classroom? Honestly, it would take a lot for me to go back into the classroom. I the experience I had more optimizations already on the list, Caleb. But I can add related rates. Related rates. What was I teaching? So my last teaching job, I taught middle school math, 6th, 7th, and 8th grade. It was at a small school, and the biggest challenge for me was I had to teach essentially 3 lessons in the span of 40 minutes to smaller groups of students and keep the other groups of students from going crazy or from causing anarchy. And all that without an assistant teacher. What's the highest math I know? The highest math I know, that's a good question. I would probably say, well, by no, let me ask you this. By no, do you mean be able to recall immediately? Or by no, do you mean what if I ever took the course at one time? Because depending on what your answer is for that, it'll give me 2 different answers. Taken. Okay, so the highest math that I've ever taken was a class called Introduction to Real Analysis. My first year I had to do something like that with students who had special needs. It was tough. Yeah, it was. I'm sure. Yeah, and it's exhausting. And then you get into the point when you have parents complaining that you're giving the students too much homework, but when you try to reduce the homework that you give them, your principal gets upset with you because you're not giving them enough homework. It's like, I couldn't win. They worked hard. Yep, I had that problem too. I had that problem as well, Hefe. But yeah, like I said, my situation I feel like I was not gonna succeed in. Yeah. Don't get me wrong, teaching is awesome. When students understand the material and you see that they understand the material and that they're growing in math, there's really nothing like it. But I personally found that when I was teaching, more of my students would understand that I felt like when I met with students one-on-one, like before or after school for tutoring, they would understand the concepts more than when I tried to teach it in class. So I'm like, maybe teaching isn't for me, but maybe tutoring is for me. So that's why I say if I ever thought about going back to the classroom, it would take a lot for me to return. So yeah, let's move on to the next one. And thank you all for the likes. I really do appreciate that. If a graph zigzag line has 4 points and they're plotted on 1, 3, and 5, would the domain be 1, 3, 5 or 1, 5? Well, we have to be careful. No problem. So that's kind of a difficult question because we would need the y coordinates too for them to be points. Because if I have just 1, 3, and 5, I don't know where on y they are. But let's assume for a second that they're connected. If they're connected, then the interval would be from my starting point to my ending point. And again, I'm assuming that the function starts at 1 and stops at 5. Or at that point, though, is it really a function, or is it anyway? Let's go ahead and try another one. Shall I try the one I received? Yeah, let's do that one next. That one looks fun. F of x is equal to the following. I have x minus x cubed all over x minus 4. And the interval that I'm interested in is 1, 3. Nebula, are you still here? And we want to show. So, show f of c is 3 exists, or equals 3 exists in the interval. So, here we go. First, I need to check and see if this is a continuous function. So let me ask you, between the numbers 1 and 3, is this function continuous? All of them are connected and they do stop at 1. Yep. So then your domain would be your starting x value to your ending x value. What math is this? This is calculus. This is Calc 1. Congratulations, Sam Payne. I'm really happy to hear that. So, is this function continuous from x equals 1 to x equals 3? You're taking Calc 1 as a freshman and we're reviewing college algebra. Cool. I'm going to assume you mean freshman in college. Because if you're taking Calc 1 as a freshman in high school, that would be that's impressive. But even if it's college, that's still impressive. Because not a lot of people take Calculus 1. Yes, because nothing between 1 and 3 will cause a discontinuity. Yeah. So here, I would be looking for division by 0. Division by 0 only occurs when x minus 4 is equal to 0. So if x minus 4 equals 0, then if I add 4 to both sides, x is equal to 4. And that is equal, even though it looks like a z. Let me make it more obvious. There we go. So, I think it's safe to say, I don't know, but I think it's safe to say that 4 is not in this interval. What do you think? I need advice if I should skip AP Pre-Calc to AP Calc AB. So, let me ask you a question. I'm not quite sure what your TikTok name is, but you're right, Kaylee. It can't equal 4, but I'm just showing I'm just showing how you could find where this is where this causes division by 0. But you're absolutely right. That said, I actually don't care about 4 because it's not in my interval. So if I'm looking just in my interval, then everything else doesn't matter, even that 4. So, we can say with certainty that this is continuous along that interval. So now that we've checked for continuity, now I'm going to plug in 1 for x, and I'm going to plug in 3 for x. So I have f of 1 is equal to 1 minus 1 cubed divided by 1 minus 4, and then f of 3 is equal to 3 minus 3 cubed all over 3 minus 4. And I want to show that f of 1 is less than 3, which is less than f of 3. Yes, freshman in college, I took my basics in high school. That's cool. So yeah, I don't remember if I answered your question or not, but how did you do when it came to algebra and trig on a scale of 1 to 10? Hey, lovely Dimples, how are you? Welcome on in. I'm glad I don't need to take calc for my degree. Still, it's not a bad class to take, Erica. Thank you for the share, lovely. In California, we took integrated math pathways. Okay. I'm not as familiar with what that I'd have to take a look. Like, congratulations, Erica. I'm really happy for you. So I don't know what it's compatible to. Okay, so when you did integrated math, how did you do in that class? Like that, unfortunately, I don't know a whole lot about integrated math because we don't do that up here in Maine. Or do we now? It's been a long time. Integrated math. 1. Okay, I think I understand. Okay. All right, how cooked are you? How cooked am I? Differential equations, physics 3 for engineers, inorganic chemistry. Well, I've never heard of inorganic chemistry before. I've heard of organic chemistry before, but not inorganic. So it sounds like you're in for a fun time, Solera. You scored A's across the board. Okay, so I would probably say that you would be good if you skipped AP Pre-Calc and went to Cal AB. Well, I forgot. I just got done with Calc last semester, but I already forgot everything. Okay. Well, that's the thing. If you don't use it, eventually you're going to forget it. Now, that doesn't mean we can't recall it, but it's going to take a little more effort to do so. Unless you learned all the identities and unit circle and trig graphs, you need to do pre-calculus. Yeah. Absolutely. And like I said, I don't know what the integrated math curriculum goes over. But I did do a 5-second Google search. And it mentions that it's algebra, geometry, and trig for integrated math 3. My pre-calc class was 6 units long. Is that normal? Did you take it in high school or college, Erica? Because how you answer that question will determine my answer. College? Yep, that sounds right. Because college only covers it for half a year. So yeah, 6 units sounds about right. Cool. All right, so if I plug in 1 for x, what would my value be? Plugging in 1 for x. What is the value of this top function? Lanning says 0. I don't know. I don't quite know how to pronounce your first name, so I apologize for that. Santiago says 0. Jefe says 0 with a question mark. Yeah. So let's find out. 1 minus 1 cubed. 1 cubed is 1. 1 minus 1 is 0. 1 minus 4 is negative 3. 0 minus 0 divided by negative 3 is 0. Bottom one is 24, you think? Might help if I can actually write. Huh? Yeah, I apologize. I don't know why tonight, for some reason, my handwriting's just off. Thank you, Idali, for sharing the live. So let's see if you're right, Hefe. So I have 3 minus 3 cubed. 3 cubed is 27. 3 minus 27 is negative 24. 24 over 3 minus 4 is negative 1. Negative 24 over negative 1. Well, we can say bye 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 to the negatives, and we can also say bye 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 to the 1. Because this is 24. And so, have we shown, is 3 between 0 and 24? And again, I promise this isn't a trick question. Thank you, DV, for sharing the live. Yes, Hefe, it is. Santiago says, sure is. Absolutely. So 0, f of 1 is 0, less than 3, which is less than 24. Okay, in sync, bye bye bye. Yep. And the thing is, I actually grew up with InSync. How old was I when Bye 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 came out? I know I was like 6 or 7. Great. Now I need to look up when InSync came out with Bye Bye Bye. And no, I'm not doing it because of Deadpool. 2000, yeah, so I was 7 years old. So yeah, so we've shown this, therefore, by IVT. Thank you, Lovely, for sharing the live. The real life days. Yep, I remember the real life. I did. I'm a 90s kid. Did I get that wrong? Oh, wow. Yep, Total Records Live. Yep. Yep, I remember that too. Carson Daly. Yep. I do remember that. By IVT. How do I want to word this? X minus x cubed over x minus 4 equals 3 is solvable between, or in the interval, 1, 3. I agree. MTV was amazing back then. VH1 was amazing too. Now they're both shells of what they used to be. They've forgotten what made them great. Or at least that's my own personal opinion. Oh, you know what? I know what I'm thinking. It's not the real life, it's the real world. How much more difficult is calc to pre-calc? That depends on how well you know your algebra and your trig. If you know your algebra and trig really well, it's not going to be much more difficult. If you don't, then we're in for a ride. But yeah. Any questions on this one? Nebula, if you're still here, I don't know if you are or not, but if you're still here, here's how you would solve that problem. Awesome. So, we'll do one or two more, and then let's call it a day. It is a jump. But again, if you got your prerequisites down, it's not going to be as bad. Math online versus in person. Okay, I might be a little biased here because I tutor online. But I like online. But that's just me. Like that, I might be a little biased. So we will try a couple more of these, and then we'll call it a day. So, ooh, this one looks fun. So, use IVT to determine if the function f of x is equal to x plus 1 over x has a root on the interval Thank you, Kay and Baby, for the follow. A lot of kids cheat online, I believe, so then they take the next class and get rocked. Yeah, I could see that. On the flip side, like if I were teaching an online class where, okay, I see your point. That's fair. Some are just, yep, and that's the thing. -1 to 1. They want the grade, the learning they don't care about. I'll. Can you show me a parabola problem? Well, let's do this problem first. So, can we use intermediate value theorem here? What do you think? Hefe says yes. Okay. Oh, thank you for the chill pizza, Rebecca. I don't know if you just sent that or if you sent that a while ago. If you sent it a while ago, I apologize, but I just saw it now. But yeah, thank you, Rebecca. So remember, part of IVT, yes, Hefe. That is going to pose an issue. Why? Yep, 0 is in between -1 and 1, right. And so, because if I let x be 0, this is undefined. And if even one part of my function is undefined, the whole function is undefined at that point. So, IVT cannot be used because function f of x is not continuous on the interval -1 to 1. Good catch, Hefe. Very good catch. Yeah, I know, right? This is good stuff. This is good stuff indeed. Now, what if I modified the interval? What if, instead of -1 to 1, I used 1 to 3? Don't feel bad. Don't feel bad at all, Hefe. Like that, I like audience participation. In fact, I would rather not talk to a brick wall, if I'm being honest with you. Because talking to brick walls isn't very fun. So yeah. Now can I use intermediate value theorem? That's right, Rose. Now the function is continuous. Yes. The function is continuous. Why? Because I no longer have to worry about that division by 0. So, at that point, now I can plug in my values of f. So I have f of 1 is equal to 1 plus 1 over 1, and f of 3 is equal to 1 plus 1/3. Plugging in 1, 3, you're right. You're right, Rose. Good catch. So now, if x is 1, what is my value on top going to be? Two, right. That's absolutely right. And now, what about f of 3? Three and a third, right. 10, yeah, it would be 10/3. Right, Joker, right, Rose. Now, is 0 between 2 and 10/3? And again, not a trick question. Joker says no. Rose says nope. Yeah, right. So, because 0 is not between these two, therefore, by IVT, f of x does not have a root on the interval 1, 3. Yeah. I feel like I get the feeling that we're starting to get I have a feeling that either we really understand this or we're getting tired. And that's okay. Because it's late at night. So, we'll go ahead and do the final problem now. Final problem. Let me make that look like an A. There we go. Final problem. And we'll end the live a little early tonight. But, to get to the final problem, let's see if we can't get to 5.5k likes. There are 6 of you in here. I know you can do it. But yeah, like I said, we'll finish early tonight. And to be honest, I'm running on about, I think it's 2 hours of sleep. So I think it's going to be a good idea to end with this problem anyway. And then tomorrow, while you're liking the live, what should we do tomorrow? I could go back to limit laws. Finish that up. Or hey, Math Tutor, how's it going? We're just about to go to the final problem of the night. We're working on intermediate value theorem this evening. Definition of derivative. That's actually not a bad idea. Yeah, that's not a bad idea. I just gave her an important lecture on the derivation of square roots. Okay. I'm not quite sure who her is, but cool. Hopefully it went well. Or have I covered limits at infinity and vertical asymptotes? I kind of did that with... I kind of touched on vertical asymptotes when we did continuity last night, but I haven't gotten into limits at infinity. So what I might do is tomorrow I might do limit laws and limits at infinity. And I think I'll be able to mix those both in. And then what is tomorrow? Or should I say later today? So it's now Wednesday morning here on the East Coast. Or it has been for the last hour. But tomorrow I'll do that. Thursday we can do limit definition of a derivative, and Friday we'll go into the derivative laws. Cool. Alright, so we are at 5.5 likes. So, let's go ahead and finish up with our final problem. We wanted a parabola. So, I have good teaching techniques. Thank you, Math Tutor. I'm really happy to hear that. So, at the same time, I don't want to make it too easy. Yeah, we'll do that one. So f of x is equal to x to the fourth plus 3x squared minus 2 equals 0. Nope, that's f of x. Show, or actually I'll write it this way. Prove or disprove f of x has a root in the interval zero comma 1. We actually haven't done a proof yet. We've done very few proofs so far overall since I got started doing these lives. So, let's go ahead and do one. So, I want you to prove or disprove this, that f of x has a root in the interval 0, 1. Is this Calc 1 or Calc 2? This is Calc 1, Kobe. Good question. So, what should I do first? Thank you, Jesus, for the follow. Or is it Jesus? I apologize if I pronounce that incorrectly. So first, I should test for continuity, right? Is f of x continuous on that interval? Yes or no? Jesus says yes. Michael says yes. Yeah. So, this is continuous on that interval. Why? Because there's no division by 0 here, nor will any value of x from 0 to 1 give me I. So, f of x is continuous. And I'm not going to do like a formal proof, but I'll do a but I want to answer that question on 0, 1. Now, by IVT, now that I have a continuous function on an interval, I can plug in my endpoints and see what they equal. So I have f of 0 and f of 1. If f were equal to 0 here, or I'm sorry, not f. Let's try it again. If x equals 0, what would f of x equal? Michael says -2. Jesus says -2. Yeah, that's right. So f of 0 is -2. And likewise, if I plug in 1, what would my answer be? If I plug in 1 for x, what would f of 1 be? Yes, Michael, it would be 2. Yes, Jesus, it would be 2. So now, final question. Is this a true statement or a false statement? Jesus says yes, true. Michael says true. Yeah, this is a true function. So therefore, by IVT, does f of x have a root in this interval? Yes, it does. Has a root in the interval. Zero comma 1. And because I asked this, I want to show that I'm done. So I'm going to write QED. So that is a Latin phrase which translates to that which was to have been shown. Quod erat demonstratum. Is 1 times 0, 0. Yeah. Yes, it is. I think you knew that already. So, with that, that is going to be it for intermediate value theorem tonight. I hope everyone had a fun time. Remember, my goal after all these lives, after every live, is for everyone in here to have enjoyed math, even if it's a tiny little bit more than when you walked in here tonight, or when you clicked on the, or when you tapped me to get into my live. So with that, I want to say thank you all for that. You're welcome, Jesus. I'm happy to be able to show calculus to everyone. Or to those, or at least to those that click on my TikTok channel. So before I go, for some reason, I'm gonna have to turn on my light here for a moment. But at this point, I think it's safe for me to shut my camera light off and turn my regular light on. So, before I go, I have my little speech to give you all, or my usual little talk. But for some reason, I can't find my note cards, which I just placed down with that information. So, you're taking big steps on your way to 1,000 followers? Yeah. Thank you, Michael. To think that like a month ago I was around, 300? I've only been live for like, I want to say, not even 2 months yet. And already I'm hitting 1,000. I'm projected to hit 1,000 followers by the end of the year. But yeah. So thank you, Michael. I appreciate that. I just joined, but as a major thank you. Math is fun and extremely interesting. Absolutely. Absolutely it is. And that's the thing, right? math doesn't have to be the big scary monster that goes boo in the night. Math, if we... Oh, I found them, I think. Well, I found 2 of them. Have a good night, Hefe. But yeah, so, with that, what was I saying? Oh, yeah, so math doesn't have to be the big scary monster that goes boo in the night. If we do math at a pace that is almost at the same pace that we do things like the crossword puzzle or Sudoku puzzle, I mean, yes, we could try and complete them as fast as we can, but I find that when we do that, we're making more mistakes than are necessary. And like I said, it's good to learn from our mistakes, but I also feel like if you're careful, you're going to make fewer mistakes than if you're fast. And for some reason, when we learn math, I'm not blaming anybody here, but for some reason, when we learn math, we learn it in such a way that we almost it's almost like answer it quickly. And yes, there are some facts that we do have to recall from memory. But in that, we also teach our students that it's better to be fast than careful. One of the things I really don't like, I used to like it as a kid, but I don't really like it anymore, are those things where in elementary school you flip over the paper and do all the multiplication or addition or division problems in a minute. I think they call it a Mad Minute, but I don't know. And I mean, Mad Minute I think is a good name for it because after a minute, a lot of students feel mad. But like I said, if we teach kids to slow down and really think through what they're doing, all of a sudden they're going to find that that math is no, I'm not going to necessarily say easier, but possible to do well at. Because there's some math out there, let's face it. There's some math out there that's legitimately difficult. There's math out there I don't even know yet. Agreed, when I tutored, I always stressed understanding more than knowing how. Yeah. Yeah, and like I said, it's like I compare it to solving a puzzle, right? You wouldn't take a 3,000 piece puzzle and say, all right, we're not going to look at it. We're just going to try and put it together as fast as we can. Complex analysis is very difficult, man, but beautiful. I've heard that. That's one course that I actually do want to look at and learn. But I found my note cards. So, let's go ahead and I will do my little spiel and we will be out of here. So, first, I want to let you know or remind everyone that I offer online math tutoring. And here is a list of every single subject I tutor. Now, or let me rephrase that. The ones that I tutor on a regular basis. So, just if a subject is not here, that doesn't necessarily mean that I can't tutor it. It just means that either I haven't run into it for a while, or I don't know it enough to feel comfortable in teaching it. But, that said, I offer group tutoring and one-on-one tutoring. So for group tutoring, I offer tutoring to groups of 3 to 10 students who are all taking the same class. Now that doesn't mean that we're taking it with the same teacher or even at the same school. So let's say that that you and 3 of your friends are all taking differential equations. It's at 4 different colleges. You can still sign up for group tutoring because you're all taking the same class, even though it's not at the same school. And if you're interested in the group tutoring, I charge $35 per hour per person. And then I also offer one-on-one tutoring. And actually, I'm running a special right now, which ends soon, where normally I charge $100 an hour for one-on-one tutoring. But if you sign up for regular weekly tutoring between now and August 31st, you're going to be locked in at this rate. So even after September comes, if you sign up before here, you're locked in this rate. Because once it turns 12:01 a.m. Eastern on September 1st, this price goes back up here. So if you're interested in either of those, please feel free to DM me. Also, if you want, there are a couple other people on here that I highly recommend. So first is ACG Math Tutoring. She's really good at getting people ready for the ASVAB, the Accuplacer, the GED, the TEAS test. She's also running a promotion right now where she's setting up a, I want to say, PSAT prep program for juniors who are going for national merit scholarships. So she is definitely someone worth following, as well as Learning with Lynette. She's actually live right now, and as soon as I am done here, I'll be jumping into her live. I studied complex analysis on my own for a year, man. It was fun. I've heard. I like that. I really am interested in learning about it. But yeah, so if you're interested in learning about the abacus, which is, I didn't think I was going to be interested in learning about the abacus, but Learning with Lynette is awesome. And like I said, as soon as I end this live, that's exactly where I'm going to be heading. And then, if you want to find me elsewhere, I'm here. And if you go here, this is my channel over here. And if you like, subscribe, share, comment, and turn on notifications, that would be awesome. Come and visit my content in my live. You would love it. When do you go live? When do you go live, Math Tutor? I go live between 3 to 4 p.m. and at night 8:30 my time. Cool. What time is it right now for you? I think you said you're West Coast, but I'm not sure. I'm not sure if I'm remembering that correctly. Because I'm over here on the East Coast. And it is 1:20 in the morning. yeah, so with that, have a good rest of your evening, everyone. And I will see you tomorrow when we will talk about limits some more. All right, have a great night, everyone. Bye now.